So I accidentally stopped the record from the previous recording, so I'll continue it here. Okay, so this is 3 from t greater than 1, okay, and 0 for t less than 1, okay, while this term, okay, is 2 for t greater than 2, okay, and 0 for t less than 2. Okay, now let us look at this interval, the interval between 1 and 2, this interval. Okay, here the first function is 3, okay, while the second function is 0, while this one is 0. So therefore 3 minus 0 is 3. That's why you have this okay. But in this case, okay, in this interval, when t is greater than 2, okay, this is 3 minus 2, okay. So therefore, the difference between them is 1. So therefore, this is essentially 1, okay, for t is greater than 2, okay. So when your step functions have different scaling factors, they actually have different graphs or different values for different intervals. Okay, so if you take a look back at this one, okay, if we take a good look at this one, um since this step functions have different scaling factors, okay, take note that the effect of this, okay, would only be would only be uh, felt, or would only have an effect for t greater than b, okay. This would only have an effect for t greater than b. I mean, these two would only subtract when t is greater than b. But when t is greater than a, okay, or essentially when t is between a and b, okay, when t is between a and b, this would only be the term that is prevalent, okay. So that is why we have here, okay, for t between a and b, okay, the only term that the only term that your uh, current will have is essentially v0 over r times e raised to a over rc times e raised to negative t over rc. Just a reminder that all of these are constants. Okay, n is defined as k1 here. So everything here, this one, is essentially defined as k1 in your answer. Okay, so essentially, this is k1 times e raised to negative t over rc, okay, between a and b. Okay, now, for t greater than b, okay, this two now gets subtracted. Again, if we take a look at this one, the effect of this term would only be felt, okay. The effect of this term would only be felt when t is greater than 2, or when beyond this t, okay, beyond this value, okay. So in that case, okay, um the effect of this will only be felt, okay, when t, okay, is greater than b. And in that case, okay, you would now have this entire thing, vo over r, multiplied to e raised to a over rc minus e raised to b over rc, multiplied to e raised to negative t over rc, okay, when t is greater than b, okay, when t is greater than b. So actually this is a t, this is a typographical error from the book, okay. If you take a good look at the book, you would have something like that. You would see that this is the same thing that the book has, okay. I just snip it out of the book, so therefore it's a typographical error from the book, okay. But that is b, t is greater than b, okay. So there, if you can see, again, we have defined this term vo over r times e raised to a over rc as k1, and then vo over r e raised to b over rc, okay, as k2. Okay, so therefore, see, this essentially is k1 minus k2. Okay, so leading to this answer. Okay, so that is your IT. Okay, that is your IT in terms of piecewise function definition. Okay, but in terms of the step function. Okay, in terms of the step function, you have this one uh, as your IT. Okay, so that is how that is what we have for example 3. Okay, now finally let's have example 4. Okay, okay, so for example 4, um we will have the following, no? So find the response or the current, basically, okay, of the RLC circuit in the figure 1 to 5. By the way, this response depends actually on what is being asked. Okay, in this case, that response refers to the current, but response may also refer to, for example, the capacitor voltage or the resistor voltage or the inductor voltage. Okay, so in this case, this response refers to the current in the circuit. Okay. Um, where E of t is sinusoidal, acting for a short time interval only. So that is our sinusoid is basically just on a limited time. Okay, that is between 0 and 2 pi. Okay, and our E of t is 0 is basically if t is greater than 2 pi. Okay, so basically since this is 400 t, no? Okay. So our angular frequency, we call that angular frequency. That's 400, which is equal to 2 pi f. Okay. So f here is basically 200 over 5. Our frequency is basically 200 over 5. And our period, okay, is pi over 200. Okay, pi over 200. Okay. So which means that if our if our sinusoid acts only on 2 pi on for a period of 2 pi seconds, okay, we would have 2 pi over 200, okay, which is 400 cycles. Okay, so we will have 400 cycles of sinusoids. Okay, so we will have 400 sinusoids acting on our circuit. Okay. So you may be able to verify this if you graph this on your on your Desmos. And by the way, if you actually write the E of t here, okay, this can be written as 100 times sine of 400t, okay, multiplied to um, u of t minus 2 pi. Okay, that would be your E of t. Okay, in terms of the step function. Okay, and no, wait, ano pala, this is since this acts on 0 between 0 and 2 pi. Okay, this should be u of t. Okay, this is u of t minus u of t minus 2 pi. So that would be your E of t. Okay, so this ensures that your 100 sine 400 pi t would only act in between um, 0 and 2 pi. Okay, so there. Uh, Now, okay, now we proceed now with again, if we want to get the current here, okay, if we want to get the current here, okay, we would like to find the we would like to write a loop equation for this circuit, okay, using KVL. Okay, we would like to find a loop equation, okay, for this circuit using KVL. Now, as discussed, you may want to use, or you may want to transform this circuit into its we're looking for I of t basically. Okay, we're looking for I of t here. Okay. And again, the easiest way to do this is to write an equivalent circuit, okay, in S domain. Okay, that is, we take the Laplace transform. Okay, we take the Laplace transform of this circuit. Okay. So in that case, let us try to do that by redrawing the schematic for your circuit in the following manner. So E of t in the S domain is E of S. Okay. Um, R, the impedance R is simply R. Okay, which is 11 ohms. Okay. The capacitor C, okay, has an impedance of 1 over Cs. Okay, which in this case, that's 1 over 10 raised to negative 2 S. Okay, or basically that's 100 over S. 1 over 10 raised to negative 2 S. That's the impedance of we will not use the unit parad here. Okay, since this is already impedance. In fact, the proper unit the proper unit here is ohms, since this is already in impedance. Okay, so we will have but let's just write this impedances as unitless, and so therefore we don't need to worry ourselves with the units as of now. And this is something that I forgot pala. They should carry a unit of ampere. Okay. Yeah, let's use ampere here, assuming that our voltage is in our input voltage is in V. This is in farad, and this is in ohms, and our unit of time is in seconds. Okay, if those are the set of units that we have, then we should write this in terms of ampere. Okay, so this should be carry a unit of ampere. This should carry a unit of ampere. Okay, so we're going back here. Okay, so we will have R here. Okay, which is 11. We have and then finally, yung ating inductor has an inductance of 0.1 Henry. So we will have this as 0.1. Its impedance is Ls. So we will have it as zero point 1 S. Okay. And then the current flowing here in your circuit is I of S. Okay. So again, the easiest way to get a loop equation, okay, in this series circuit. This is called now an RLC circuit, or series RLC circuit. Okay. So the easiest way is to add up the impedances. So that is 11 plus zero point 0.1 S plus 100 over S. Then multiply this with the current I, okay, and then equate it to the input voltage. Okay. So here, what we will do now, okay, is to solve for current. Okay. We will now solve for current here. So we will have before that, let's express this in terms of a single rational term. Okay, so we will have something like zero point 0.1 s squared plus 11s plus 100 divided by s multiplied to I equals e. Okay, and remember that e is what we have obtained here. Okay, so we will try to incorporate that later on. I'll try to use this. Okay, so now let's have I. Okay, let's have I here. Okay, this is 2 naman. Okay, so let's have I here equals s over zero point 0.1 s squared plus 11 s plus 100. Okay, multiplied to e. And also, let's make the leading coefficient of this x squared to be equal to to be equal to 1. Okay, let's make it, let's make this to be equal to 1. So we multiply this by 10. Okay, because 0.1 times 10 is equal to 1. So we multiply everything by 10. So this becomes 10s divided by s squared plus 110s plus 1000. Okay, multiplied to e. That is your I. Okay. Now, e again, as we recall, okay, is this one. So this is e uh, e of t, no, equals 100 sine 400t uh, multiplied to e u of t minus u of t minus 2 pi. Okay, so that is your e of t. Okay, and then we take the Laplace transform of that. Okay, so we make it e of s. Okay, so here, okay, this would be okay. Okay, this would be okay because 100 let's try to expand this one first. Okay, so we will have something like 100 sine 400t times u of t. Okay, and minus 100 sine 400t times u of t minus 2 pi. Okay, so for the first term, okay, for the first term, this is simply 100 sine the Laplace transform 100 sine 400t um, times u of t, or simply if you take the Laplace transform of that, that's simply 100 multiplied to 400. Okay, so because this is your omega, so this is the Laplace transform of sine omega t, okay, is omega over s squared plus omega squared. Okay, so we have 400 here, and then multiply to 100 the constant, so that's 400 times 100, so that should give you 40,000. Okay, divided by s squared plus 400 squared. Okay, that's the first term, the Laplace transform of the first term, this one. Okay, while here, okay, since this is being multiplied by a delayed sinusoid, I mean delayed step function. Okay, we will use uh, the second form of the statement for your Laplace transform. Okay, which is the Laplace transform of f of I mean, yeah, the Laplace transform f of t u of t minus a, okay, equals e raised to negative as multiplied to the Laplace transform of f of t plus a. Okay, so if we let our f of t, okay, equal 100 sine 400 t, okay, then f of t, and here take note that a is 2 pi, no. Okay, so f of t plus a, therefore is 100 times sine of 400 multiplied to t plus 2 pi. Okay, or basically this is 100 sine of 400 t plus 800 pi. Okay, now let us inspect. Okay, let us inspect what happens to this 400t plus 800 pi. Okay, by graphing, no. Let us inspect its effect. Okay, so here's the original function. This is 100 sine 400t. Okay, now recall that what we want to compare, okay, is this original function. Okay, we want to compare this original function and this shifted function. Okay, so which we will shift by 2 pi. Okay, and here's what you are going to observe now. Okay, again, if we shift now this function by 2 pi, if we shift t by 2 pi, okay, the resulting function is now 400t times 800 pi. Okay. If we actually graph this one here, okay, what you would observe now is that you now have this function. Okay, and observe that, okay, they are equal. Okay, so essentially this f of t and f of t plus a is basically equal. Okay, are basically equal. Okay, actually you can prove that analytically by um trying to expand this one. This is 100 um sine 400t cosine 800 pi, okay, plus 100 cosine 400t sine 800 pi, okay, which in which we use sum of angles identity, something like sine of a plus b, okay, which translates to, or which is equal to, sine a cosine b plus cosine a sine b. Okay, so in that case, if we actually take a look at cosine of 800 pi, okay, if you take a look at cosine of 800 pi, um, that basically translates to 1, okay, because 800 pi, okay, um, is a multiple, okay, of 2 pi, okay, um, multiple of 2 pi siya, 2 pi times n, okay, where n here, in this case, if this is 800, this n here is 400, okay, so therefore, multiple siya ng 2 pi, okay, and any multiple, okay, if you actually observe, any multiple of 2 pi n, the cosine of any multiple of 2 pi n uh, is actually 1, while the sine of any multiple of let's do it again. The cosine of any multiple of 2 pi n is 1, while the sine of any multiple of 2 pi n is 0. Okay, so essentially this term becomes 0 because of this term. Okay, because of this factor. Okay, and this becomes 100 sine 400t, okay, times 1. Okay, because of this factor. Okay, so therefore we see that f of t plus a is 100 sine 400t. This is also confirmed with the graph that we have here. So they are equal. Okay. So basically, what we will have to be able to apply now the Laplace transform of the second term. Okay. We essentially just have to simply multiply this. Okay. This is we will have this the same thing because this is the same Laplace transform that we have it already. Okay. So we will have 40,000 over s squared plus 400 squared. But this time, because of this step function, okay, we will multiply this by e raised to negative 2 pi s. Okay, so that is basically your Laplace transform. Okay, so now we now have I now, okay, or I of s now to be equal to 10s over s squared plus 110s plus 1000, okay, and then multiply by 40,000 divided by s squared plus 400 squared. Okay, now let's have this first as, or something like 1, okay, minus e raised to negative 2 pi s. Okay, so essentially what we will just have, we express this the I of s in this form, basically because we would like to just get the inverse of Laplace transform of this one. Okay, we would like to get the inverse of Laplace transform of that factor, and then essentially what we will have, if we apply the second shifting theorem for this factor, okay, we will essentially have something like u of t minus u of t minus 2 u of t minus 2 pi. Okay, so we will be able to see that later on. Okay, because essentially this is e raised to negative 0s, in which if you apply, okay, the inverse of Laplace transform for this one, okay, this is basically f of t minus 0, u of t minus 0, and f of t, okay, is this one. Okay. While for this one, this is e raised to negative 2 pi s. Okay. So its inverse Laplace would become f of t minus 2 pi. Okay. U of t minus 2 pi. So essentially, we'll start with f of t, which will come from here, the inverse of this one. Okay. And then replace all of these here with 2 pi. Okay. And then multiply this with u of t minus 2 pi. Okay, so the central problem of taking the inverse of Laplace form of this would essentially start from taking the inverse of Laplace form of this term. Okay, so there. Okay, so this might be a bit of a complicated problem for us, but we can take it step by step. Okay, and then later on, you might be if this problem is kind of simple enough, then we will be able to use uh MATLAB or Octave for this one. Okay, so but we will have to break this down first, this problem first. Okay, so so now let us multiply this. Okay, so we will have something like 400,000 s divided by um, okay um I would like to take note that this quadratic factor, because you have two quadratic factors here, no? Okay, so and obviously this quadratic factor is not factorable. Okay, but you have to take a look at this one and try to determine whether this is factorable or not. Okay, you may be able to find two factors, 100, um, negative 10 and negative 100. Okay, um, that would correspond to the roots of this, and therefore this can be factored as s plus 100 and s plus 10. Okay, take note that the sum of this is 1000. I mean, the sum is 110 and the product is 1000, so therefore these two are the factors of this. So while we have s squared plus 400 squared. Okay, so therefore we will have the following partial fraction expansion. So we will have a over s plus 100 plus b over s plus 10, and then plus cs plus d, because we are dealing with a quadratic factor, so we need two factors. So we have cs plus d over s squared plus 400 squared. Okay, now a and b, because they have they have denominators, they have linear denominators. Okay, their denominators are of linear form. Okay, can be solved using cover up method. Okay, so that is a can have 400,000 s. Okay, divided by, we'll remove this s plus 100 factor here, so we will have s plus 10 uh, s plus 10 times s square plus 400 square. Okay, when s is negative 100. Okay, so we compute that as 2.6, that is 2 point where is it, yeah, 2.6144. 2.6144. Okay, what I did here was to type in 400,000 x all over x plus 10 um times x square plus 400 square, and then press calc. Okay, and then press negative 100. So that essentially substitutes negative 100 to x. Okay, and that results to 400 over 153. And using just simply a truncated decimal, we will have 2.6144. Okay, that's for 8. Okay, so we may want to store this to a. Okay, so that we will use it later on when we compute c and d. Okay, so that we will be using exact values. Okay, or we can take note of here that this is 400 over 153. Okay, now b, for letter b. Okay, so this is again, I'll cover up this factor here, so I'll have 400,000 s divided by s plus 100 multiplied to s plus 400 square. Okay, when s equals negative 10. Okay, which again can be done here. Okay, let's just simply replace this with x plus 100. Okay, and then calculate this when x is negative 10. Okay, so that should give you negative, just for writing this in exact value. Okay, so this is 4,000 divided by 14409. 14409. But in decimal, which we will report later on, this is negative 2.776. Negative 2, negative 0.2776. Sorry, 76. Okay. Negative 0.2776. Okay, so that's B. Now, C and D cannot be solved by cover up method. Okay, so we resort now to multiplying everything. Okay, multiplying everything with the denominator. Okay, this denominator. Okay, so that what remains is the numerator. On the left side, what remains is the numerator. This 400,000 S. Okay, and then A here cancels out what essentially we have multiplied. Okay, what essentially we have multiplied is the what essentially we multiplied here is this factors. Okay, so when you multiply these factors with this one, this and this cancels out. Okay, so what is left that is multiplied to A, okay, is s plus 10 multiplied to s squared plus 400 squared. Okay, for B, this is s plus 100 multiplied to s squared plus 400 squared plus cs. Okay, I'll separate the two. Okay, so that I'll have an easier look at C and D. Okay, so cs, what would be left is we will this and these factors would get eliminated. Okay, so what would be left of is s plus 100. Okay, and s plus 10, and same thing with D. Okay, which is now s plus 100 and then s plus 10. Okay, now what we would want to do here is to equate like powers of s. Okay, so the highest I think the highest power of s here is s cube. So this is s cube now. Okay, so that's the highest power, s cube. So on the right side, there is no term that contains s cube. So therefore, the coefficient of s cube there is 0. While on the left side, these are the terms. Okay, these are the terms that would produce s cube. If you multiply this and this, so that's s cube, and a gets to be multiplied. If you actually expand this now, you would want to expand this, and then what would happen is that you would have an s cube term there. Okay, and that s cube term there has a coefficient of basically a. So we'll just simply write here a. Okay. Here there's an s cube if you multiply this and this. So that basically is b. Okay. Here there's an s cube if you multiply this with this and this. So that's basically c. And then here there's no s cube because there's no possible combination here that would produce s cube as a product. Okay. And since we already know what is a and b, okay, we can now solve for c. Okay, that is the wonder of the cover up method. Okay, if some of your factors or if some of your partial fraction terms have linear denominators, you can actually solve them immediately. Okay, and then try to and then the rest of the solution should actually be shortened. Okay, because you don't have to really subtract for those partial fraction terms. Okay, having linear factors as denominators. So here we can readily proceed with C. Okay, so C here is so let's not use the exact formula, the exact value already. Let's just use this one. Okay, we just know that our answer here would be correct to 3 decimal places. Okay, so here we have negative a minus b. Okay, so that's essentially is negative 2.6144 plus 0.2776. So that should give us um, negative 2.6144 plus 0.2776. So that should give us negative 2.3368. Negative 2.3368. Okay, that's your C. Okay, while D. Okay, so let's find now those factors that would produce s squared. Okay, so if you multiply this and this, s squared, no? Again, on the left side, there's no s squared term, so therefore the coefficient of that is 0. Okay, so if you multiply this and this, you would have s squared term. Okay, so you would have 10a as its coefficient. Okay, while here you would have this and this. Okay, if you multiply those two, okay, you would have 100b. Okay, 100b. Here, if you multiply, you would have something like this multiplied to this and uh, this. Okay, so that's cs squared. I mean 100 cs squared. Okay, so plus 100 cs squared. And then also this product, this and this, okay, produces also s squared. Okay, so and that is 10. So basically, let's just make this 110. That's 100 plus 10. So that makes it 110. Okay, so let's just make this 110 cs squared. Okay, let's remove s squared. Okay, because we're just taking coefficients here. S squared is produced when you multiply this and this. So that's basically t. And then, since we already know what is a, b, and c, okay, we can just simply proceed in solving for d. Okay, we can proceed in solving d. Okay, so which is now 10 negative 10a minus 100b minus 110c. Okay, so that should give us negative 10 times 2.6144 minus 100 times negative 0.2776. Okay, and then minus 110 multiplied to negative 2.3368. Okay, that should give us the value of d, okay, as negative 10 times 2.6144 minus 100 multiplied to negative 0.2776 minus 110 multiplied to negative 2.3368. So that results to 258.66440. Okay, I'll report this as 0 because this is an uncertain value. Okay, so okay, the inverse for this can be easily written. Okay, this is basically an exponential, a time domain exponential. Also here, this is time domain exponential. But here, this is needed, okay, to be able to by the way, this should be negative now. I have written this as positive earlier. Okay, so since d is positive, and I made this negative, the if I should distribute this negative sign into this, and into this, okay, c should end up as negative, and this should be end as positive. This should end as positive. So therefore, this should be negative. Okay. So ito is exponential, time domain exponential. This is time domain exponential. These two can be separated into two terms. Okay, one leading to a cosine term, and the other one leading to a sine term. Okay, so let's do that. Okay, so this one, we have 2.6144 over s plus 100. Okay, this one is 0.2776 over s plus 10. Okay, and then this is negative 2.3368s over s squared plus 400 squared, and then plus, okay, 258.6640 divided by s squared plus 400 squared. Okay, so what we can do now, okay, what we can do now is we will now have the inverse transform. We will now have I of t here. Okay. Which is the inverse transform of this one. So this is 2.6144 e raised to negative 100t. Okay. While this one is 0.2776 e raised to negative 10t. Okay. Here, this is we have to write this one first as an in compliance with table 6.1 number I think number basta yung sa cosine. Okay. This should be written first as 2.3368 over 400 square. Okay. Multiply to 400 square. No, sorry. Um, hindi pala ganun yung ano niya, yung sorry. This is simply just we just take out the constant, okay, which is 2.3368, and then the inverse of this is s over s. What remains is s over s square plus 400 square, which its inverse, okay, is essentially cosine of 400t. Okay. And then this one, ito yung kailangan ng pagbabalance. Okay. So we will set aside 258.6640. Okay. Multiply this. Dapat 400 square ito. S square plus 400 square. And to retain the original value, we have to divide this with 400 square. Okay. So this is 0.0016. Okay. So this is 00. Plus 0. Ito yung ratio na yan, 0.0016. Okay, and then this, yung inverse ito, is sine of 400t. Okay, so ayan. And let's label it as as I1 of t. Okay, so let's label this I1 of t. Because essentially, yung I of t natin, okay, reading from this form, okay. Yung I of s natin, okay, sorry, not I of t yet, but I of s, okay. Yung I of s natin is I1 of s, and then multiply to 1 minus e raised to negative 2 pi s, okay, negative 2 pi s, okay, ito, this negative 2 pi s here, okay, ito yung sinunod ko. So ito yung tinutukoy kong itong term na to, itong factor na to, I mean, is referred to as I of s, which nakuha natin yung inverse Laplace niya. Okay, so let's just call it I of s, no? Now, yung inverse Laplace nito, okay, this is essentially I of s multiplied to 1, okay, minus I1 of s multiplied to e raised to negative 2 pi s. And if you actually take the inverse Laplace transform of that one, okay, we will now have I of t, or I1 of t. Okay, this is your entire I1 of t. Okay, and then minus I1 of t minus 2 pi. Okay, u of t minus 2 pi. Okay. You may want to apply this thing here. Okay. Say for example, this might take a quite complicated form. So we might just leave it as this one. Okay. With I1 of t equal to this term. Okay. So kasi magiging komplikado siya for that might complicate our equation further. Okay. What you may want to do here, okay, after which is you may want to graph na lang. Okay. Kasi graphing this this equation might be a little more this might be a more this might give us a more vivid look at what the output would look like. Okay. So but before I graph, let me just make some corrections here. May nakita pala akong mali doon sa ginawa ko. here at this point. Okay. Hindi pala dapat 400 square ito. This is just simply dapat 400 lang. Okay, kasi nga pala omega over s square plus omega square nga pala siya. Okay, so this should have been 400 lang, no? Okay, so this is 400, this is 400. So that should end up as ano lang, sorry. That should end up as simply ayun, 0.6467. Okay, so dapat ito ay okay, so this should have been 0.6467. Okay, so which in that case, pero ito pa rin naman yung magiging inverse niya kapag ginamit natin sa ano. Okay. So, let me just so when we take a look at its graph, okay. Okay. So let's start off first with with the first with this one. Okay. Simulan natin siya dito. Okay, kasi basically this is the very basis of our Okay. Just take note that in the second term, we will just delay it by 2 pi. Okay, and then we will subtract it from the original Okay. Pero basically, we will have 2.6144 e raised to negative 100 pi 100t minus 0.2776 e raised to negative 10t minus 2.3368 cosine 400t plus 0.6467 sine 400t. Okay, that's your I1t. Okay, ito yung graph niya. Okay, so as you can see, it would start with a very high spike, as in high, very high. Ayan, napakataas niya. At yan ay nasa negative part, nasa negative part pa. So basically, wala yan sa natin. Okay, wala yan sa ating analysis. Okay. Pero basically, it would, sige, tanggalin natin siya by actually multiplying this. Okay. By actually multiplying this with u of 0. Okay, so let's just, so yun. It would start with a with a high spike here. Okay, at very close to 0. Okay, so mga yan siguro. Okay, something like 3.458 volts, amperes. Okay, and then eventually it would go down. Okay, that would go down. Okay, that spike would go down. Okay, until maging sinusoid siya. Okay, magiging sinusoid yan somewhere here. Okay, that is because these two terms are these two exponential terms would actually decay. Okay, una since these exponential terms have negative exponents, they would eventually become 0. Okay, as t goes high enough so that the exponent of e here becomes essentially 0. Okay, so kumbaga magde-decay these two terms, okay, would decay to 0, as your t approaches a certain value that is high enough for it to be considered as for the product negative 100t and negative 10t to be very negative. Okay. So that's the first thing. So what would happen is may iwan tong sinusoid niya. Okay. After some time may iwan yung sinusoid niya. Okay. So actually in Desmos medyo mahirap mag-zoom in, no. Okay. Pero you can adjust this part. Okay. Say for example, let's start this from pi over 20, no. Okay. So you would see na some time here, okay, the value of your the peak value of your sinusoid of your oscillation would actually be settled, okay, or would actually assume a constant value. Siguro mga some time dito. Okay. Look at the y value, ha. Okay, so Ayan, mga 2.4, something like 2.4. Okay. So that would be its its peak value. Okay. Let's see. Y equals 2.4. Ayan. And negative 2.4. Y2 equals negative 2.4. This is y1, okay, of t. Okay, and this is y2 of t. Okay, so those are the upper and the lower limits of yun. Pero as you can see that it would take time to actually reach that that value, that peak, that certain value. Okay? So again, ang explanation dun is that the first two terms would actually take time to decay. Okay? It will actually take time to decay to 0. Okay? When t assumes a value so that negative 100 times t and negative 10 times t becomes essentially very large to the exponent, that we can consider e raised to negative 100t and e raised to negative 10t to be 0. And what is left would be a sinusoid. Would essentially be a sinusoid. Okay? Um, so that's basically yung base function natin. That's I1 of t. Okay? Now, if we actually delay that, okay, if we actually delay that by 2 pi, okay, and then multiply it by 2 pi, you would have the same version. Okay? You would have the same version of that. Okay? It's just that the function would start from 2 pi. Okay? So, essentially, ito yun. Here, yan. That same version of the signal. Okay. Ito yung term na to. Okay, that's this second two terms. Okay. The second two terms. Okay. So, you might you will notice that they have the same shape, the same It's just that it now starts at 2 pi. Okay. Now imagine that if you subtract the 2. Okay. If you subtract the 2. Okay. What will happen is that at some point somewhere here where the exponents now where the exponential now has essentially derived, siguro mga somewhere dito. Okay, somewhere at this point. Okay. So yung dalawang yung sinusoids niyo from the first from this term, okay, from this term and from this term would actually subtract each other out. So therefore magsi-zero na rin siya. Okay. And what would be left after 2 pi is a very small portion of your exponential. Okay? Kasi nga magka-cancel out tong sinusoids nandito. Take note, I'll just write this term, itong second term na to. This is I t minus 2 pi u of t minus 2 pi. So magiging ganito yan, 2.6144 e raised to negative 100 t minus 2 pi minus 0.2776 e raised to negative 10 times t minus 2 pi minus 2.3368 cosine of 400 t minus 2 pi, okay, plus 0.6467 sine of 400 t minus 2 pi. Okay. You may be able to verify. Okay, you may be able to verify later that ito at saka ito. Again, ito na verify natin kanina that this is the same as sine 400t. Okay. Ito naman this one is also the same. Okay. This cosine 400t minus 2 pi, okay, is essentially the same. Okay. Yeah, they're essentially the same. So this becomes by the way, take note that this is minus already now. So you may want to verify this with the expansion that they are the same. Kasi ang na-verify pala natin kanina is sine of 400 times t plus 2 pi. So kung sine of 400 t minus 2 pi yan, this is sine 400 t sine cos of 800 pi. Okay. Minus, okay, pareho lang. Okay. So, dito tingnan nyo rin. This is cosine of 400 t minus 800 pi. Sabi ko tingnan nyo, pero ako na, titignan ko na rin. Okay. So, this is cosine of 400 t cosine of 800 pi plus cosine of 800, sorry, cos sin sine, sorry, sine of cos 400 t sine of 800 pi. So, ito mag-0 to. Ito, this is 1. So, pareho lang din. Okay, so this is still cosine of 400 t with the same signs. Okay, so basically, itong dalawang to ends up to be whether you decay it with whether they are not delayed, not shifted, or shifted by 2 pi, they end up essentially as the same. So, ang magiging difference lang talaga nila is itong dalawang to, yung exponential. Okay? And that difference, by the way, I'm talking about for t greater than 2 pi, for t between 0 and 2 pi, this will prevail. Okay? Ito yung nandun. Okay? Ito yung nandun sa natin. Okay? Sa graph natin. Okay? Dun sa IT. Okay? I'm talking now about when t is greater than 2 pi. When t is greater than 2 pi, these two would cancel each other out. Ang may iwan is yung difference nito. Okay? Is yung little difference yung dalawa. And essentially, when t is greater than 2 pi, ito essentially 0 na to. So, ang may iwan na lang dyan, ito na lang talaga. Okay? So, if you subtract them, okay, if you would subtract those two, ito yung may iwan ngayon. Yan. Okay. So, as you can see, you have the same graph, okay, as I of t. Okay, you have the same graph as I of t. Okay. Yun nga lang pagdating sa 2 pi, okay. Okay. At beyond 2 pi, okay. There is this very very small, yan. Ito yung sinasabi ko. There is this very very small fluctuation that is left until that exponential is 0. Okay. That current becomes 0. And this itong part na to, okay, is produced by the difference of this and this. Okay. So, ayun. Now, how do you express the final answer? Baka you might be wondering, how do I express the final answer of this one? I am not really particular with how you express the final answer. I would actually be more particular if naintindihan nyo yung final answer. If you are able to understand what the final answer means. Okay. So that is why I am what I am trying to explain is I would like you, if it is possible, I would like you to express the answer or illustrate the answer in a graphical form. Kahit ganito na lang. Okay. You might have some expression. Of course, bago ko nakuha to, I have my expressions here. Okay, so you might have some expressions here, but here I did not really specify ano yung exact or explicit form of my final IT. But I was able to demonstrate this with this one, and I was able to say that between 0 and 2 pi, okay, between 0 and 2 pi, my IT, okay, is basically I1, okay, I1 of t between 0 and 2 pi, okay, and the difference, okay, between I1t and I1 of t minus 2 pi for t greater than 2 pi. Okay. Pwedeng ito na lang yung final answer na i-express nyo. Again, specified here. I1 of t was specified naman. And then, try to include this graph. Okay. With an explanation that for your graph looks like this. Okay, so your graph looks like this for t, sorry, for t between 0 and 2 pi. Okay, and looks like this. Okay, uh, for t greater than 2 pi. So pwede naman ganun. You can express your answers in those manners. In those manner. Okay, either you if an explicit expression is not that easy to you might want to show that you understand what the final form would actually be. Okay. So, ayun. So that ends up our discussions on article or on lesson 3.1.